Did you declare it on the stack? If you declare it on the stack, that's fine. If you declare it on the heap, it's not going to happen.
I have no idea the answer.
Did you use new?
No, we didn't.
Then it was on the stack. C++ has a ton of gotchas. All right, shallow copy versus deep copy. We actually talked about that. Shallow copy just copies the pointer value over. A deep copy, when you create a class, is going to copy all the elements over as well. For example, if you have an array called first, and you create second, a shallow copy just has second point to the array. A deep copy, which is not shown here, great. A deep copy would have taken this whole array and have second point to a new array in memory with all those elements in there. So a deep copy creates a copy of everything. A shallow copy just copies over the pointer.
So basically, with the deep copy, you would do like a whole new int, but with the shallow copy, you just probably create a variable with the star.
You got it. And after the deep copy, when you create the new int, you need to actually copy the values over as well.
Individuals, right?
Yep,
Okay.
individually. I'm not going to get to mem copy today, so just do it individually. All right. Classes and pointers, some peculiarities. All right, cool. So object 1, object 2. Object private has x, len p, and a pointer to an integer, colon p. You create these two objects on the stack. Why are they on the stack? Because there's no pointer variable in front of it, so C++ will automatically create that on the stack for you. And, okay. Object 1 goes out of scope, its member variables are destroyed, but the pointer, if the destructor ensuring that the object 1 goes out of scope, the array memory is deallocated. So if you're over here, what they're saying is, let's say you have object 1, object 2, they're both pointing to the same piece of memory. And then object 1 goes out of scope, it's on the stack. Since it goes out of scope on the stack, it's automatically going to call its destructor. The destructor would deallocate this piece of memory. And then what error do you have? Logic error. What's P going to be pointing to of object 2? Mm-hmm.
Undefined.
Actually, it's very well defined. It's pointing to wherever this was, but this has been deallocated. Why is that that?
Go out of scope. Well, right.
Oh, so object 1 went out of scope. The destructor was called, deallocating this array right down here. But object 2 is still in scope, let's just say, and its p variable was pointing to the same thing. What would happen if you try and dereference that p variable afterwards? Hopefully, undefined. So you were kind of right. Segfault, hopefully a segfault, maybe undefined. The point is, this is the problem with the shallow copy. If you just copy the pointer over, you have multiple objects pointing to the same thing, and if you destruct something or deallocate, you may not, you may be messing up someone else's object. This is why you need to do, this is why you should always do a deep copy, unless you have a very strong performance reason. Getting the what's going on look. You okay, David?
Yeah.
Oh, okay. Yeah, letting it all sink in. Yep. All right, copy constructor. We actually went through an example of this. This is when you have a constructor that's passed a pointer to an object that's its own type. And we'll talk about this more in the lab today. All right, that's nice. Okay. I'm going to talk about virtual functions. Oh, we got to do virtual functions. I'm going to stop here. I'm going to stop here, and we're going to do the evolution of a makefile.